In a speed-time graph, this graph represents the motion of a particle accelerating from speed u, the initial speed at time 0, to speed v, the final speed at time t. When we draw the speed-time graph, usually on the y-axis we have the speed, while on the x-axis we have the time. Now, from a speed-time graph, I can get two things. The first is the gradient, which is equivalent to the acceleration, which is equivalent to v minus u over t, where v is the final speed, u is the initial speed, and t is the time. Also, I can find the distance traveled by the particle by calculating the area under the speed-time graph. In this example, it says a cyclist is moving along a straight road for 12 seconds. So the time on the x-axis is from 0 till 12. For the first 8 seconds, she moves at a constant speed of 6 meters per second. Then she decelerates at a constant rate, stopping after a further 4 seconds. So in the first 8 seconds, she moves at a speed of 6 meters per second. Then from 8 to 12, she starts decelerating until she reaches back to 0 speed. Now, if I tell you to find the distance traveled in the first or the distance traveled during the time of the journey, so the distance is equal to the area under the graph. So it's the area of this rectangle plus the area of this small triangle. So adding the area of the rectangle and the area of the small triangle is equivalent to the total area under the curve, which is the total distance traveled by the cyclist during the time 12 seconds. So the distance d is equal to the area of the rectangle, which is 8 times 6, plus the area of the triangle, which is half, times the base, which is 12 minus 8, so it's 4, times the height, which is 6. So it's equal to 48 plus 12, and the answer is 60 meters. Now, if I tell you to find the deceleration of the cyclist during or from 8 seconds till 12 seconds, so the deceleration is simply the gradient. So here, at this point, the x is 8, the y is 6, while at this point, the x is 12 and the y is 0. So the deceleration is equal to the change in y over the change in x. So it's y2, which is 0, minus y1, which is 6, over x2, which is 12, minus x1, which is 8. So it's negative 6 over 4, and this is equivalent to negative 1.5 meters per second squared.